All right, Unit 9, practice test. Question 1, what is the value of 12p6? So this is a permutation problem. So our 12 is our n value, so we get 12 factorial over 12 minus 6 factorial, which equals 12 factorial over 6 factorial. And we can write the top as 12 times 11 times 10 times 9 times 8 times 7, we're in a space, 6 factorial over 6 factorial. And we are going to cancel those out. And what we're left with is 12 times 11 all the way down to 7, which equals 6, 6, 5, 2, 8. Question 2 is how many ways can we choose 5 toppings from a list of 11? So this is a combination problem. So we could write it as 11C5. That's 11 factorial over 5 factorial in front, and then 11 minus 5 factorial. The bottom will end Earth. So we get 5 factorial times 6 factorial. 11 times 10 times 9 times 8 times 7 times 6 factorial. And those cancel out. So we're left with 11 times 10 times 9 times 8 times 7 divided by 5 times 4 times 3 times 2, which equals 462. Okay, you are packing a bag for a trip. You have 9 shirts, but can only fit 4. And we have combinations. So we have a combination problem again. It is 9C4. That's 9 factorial. 9 minus 4. And then we can write that as 9 times 8. 6 times 5. That's the multiplication there. Boom, boom, those are gone. And then the calculator, we get 126, I believe. 12 horses in a race. How many ways can the horses come in first, second, and third? So this is a permutation problem. We get so 12 factorial over 12 minus 3. Doing that in my head. So 12 times, oh, this is going to become 9. So 12 times 11 times 10 times 9 factorial all over 9 factorial. Those are gone. 12 times 11 times 10 is equal to 1,320. Okay, we have a free ticket for boat ride. You can bring 3 friends. Unfortunately, you have 7 friends who want to come along. How many different groups of friends could you take with you? So this is a combination problem. 7C3. So 7 factorial over 3. Oh, this should be a 3 here, not a 4. Math in my head. Okay, so 7 times 6 times 5 times 4. Those are gone. 7 times 6 times 5 over 3 times 2. 3 factorial is actually 6, so you can just cross those off. And 7 times 5 is 35. You're having dinner at a restaurant that serves 3 pastas, 2 different flavors of sauce, and 3 different salads. So all you do is you take these numbers and you multiply them together to find out how many combinations that we can have. 3 times 2 times 3, which equals 18. All right, so you're packing for a bag for a trip. You're packing a bag for a trip. You have 8 shirts and 3 pants, but can only fit 4 shirts and 1 pant. So 8 shirts. You can only bring 4, so that's a combination, 8C3. And we'll multiply that by the number of pants that we can bring, which is going to be 3C1. I'm not going to do the, sorry, this should have a 3. This should be a 4. 4, there you go. And if you put that in a calculator, you get 210. How many ways can you arrange the letters of the word Google? So we have 6 letters, so 6 factorial. And we have 2 G's, so that's 2 factorial, and we have 2 O's in the middle, also 2 factorial. 6 factorial equals 720. And 2 factorial times 2 factorial is 4. 720 over 4 is 180. Okay, so what's the probability of pulling a blue marble out of the bag? So we have 8 small red, 4 small green, 2 small blue, 10 red, 9 large green, and 5 large blue. So let's find out how many blues we have total. We have 5 and 2, so that's 7. And how many marbles do we have in total? 8, 4, and 2 adds up to 14 small. And then we have 10, 9, and 5, which is 24 large. So 24 and 14 is 38. You put that in a calculator, 7 over 38, and you get 0.18 or 18%. What's the probability of pulling a green marble or a small marble? So we have 14 small, we know that already. We're not going to count these 14 or these 4 small green marbles because we've already counted in the small category. So you have to add 9 more large green marbles. So 14 plus 9 is 23 over 38. And in the calculator we go, we get to 0.605, which would round up to 61%. What's the probability of pulling a small marble out of the bag, replacing it, and then pulling a large marble? So we're going to have a multiplication problem here. So a small marble is 14 over 38. And a large is 24 over 38. 14 times 24 is 336. And 38 times 38 is 1444. 336 over 1444, and the calculator gives us 0.23 or 23%. What's the probability of pulling a small marble out of the bag without replacing them pulling a large? So it's basically exact same numbers. The only difference is we're going to have 1 less marble when we pull it out the second time. So it's 14 over 38 times 24 large. There's only 37 marbles in the bag now. So still 336, but the bottom, the denominator is now different. That is 1406. In a calculator, that comes out to be 0.238, which would round 24%. All right, so we have a table here. We've got to fill the table out first. So green, we have 30 and 10, which adds to 40. Then 10, 30, 25. Adds to 70, so what are we missing for the other? Well, 10 and 30 is 40. 40 plus 25 is 65, so we have 5 marbles that are other. 5 and 10 adds to 15. We can figure out what this one is by doing some subtraction. So 130 minus 35 minus 40 minus 15 will give us 40. And then to get our female right here, it's going to be 15. And finally, we'll add up all the females, and that adds to 60. Now, with the probability of pulling a green, actually, I know what this context is. Oh, it's an M&M. So what's the probability we pull a green M&M out, or favorite, a person's favorite M&M is green? It's going to be 40 over 130, which would equal 0.307 or 31% in the calculator. Male or red? So we have 70 males and we have 40 reds. However, this 25 is counted twice. So we got to do 70 plus 40 minus 25, which gives us 85 over 130. And in a calculator, I didn't do that earlier. Sorry. So 85 divided by 130 gives 65%. Male and blue. Male and blue is 10 over 130. And that is 8%. Now this one, red given male, what we're doing here is we're hiding all the females. You only care about males. So how many males do we have? We have 70. And how many of them prefer red? It is 25. 25 over 70 is equal to 35.7% or 36%. Okay, we have a Venn diagram. Probability that we get F. Well, first off, let's add up all these numbers. 12, 18, and 30 adds up to 60. So that's our denominator. And how many are F? Well, we have 12 that are F only, and 18 that are F and R, which adds to 30. I'm not going to do percents this time. I'm going to go through this a little quicker. R. Okay, so we have 18 R's. Sorry, 30 only R's, and then 18 that are F and R. So 30 and 18 is 48 over 60. F or R, that's everything. 60 over 60. F and R is a middle number, so that's 18 over 60. F given R, so we only care about the R, so we're going to hide this one that's only F. 30 plus 18 is 48. And how many of these are also F? That's 18. Now backwards, we're going to hide the R's. We only care about, we're given F only. So we have 30 F's, and of those 30, 12 is, actually 18 is also R. So 18 over